Here's a new method for solving systems called solving by substitution. We're going to write the steps first, and then you'll see how it works in a couple examples. Okay, so here's how you do it. Start by substitute an equivalent expression. Substitute an equivalent expression in for a variable. Okay, what does that look like? Okay, we're gonna see equations that look something like this. Y equals 3x plus 4, something like that. Okay, now the variable is y. Okay, the variable is y. And the expression that's equivalent to the variable is 3x plus 4. Okay, so this variable and this expression are equivalent. That's what the equal sign means. So you're going to be looking for variables that are isolated, that are by themselves on one side of the equal sign. And what that's going to mean is that this variable, this y, is the same as this. So let's say this y is 5, then this expression, however the x value needs to be to equal 5, that's what it's going to be. Okay, we'll see what that means in a second. Okay, now you're going to have an equation that has just one variable in it. Okay, you'll see, and you're going to solve for one variable. So you're going to get one variable first, right? Because remember, when we're solving a system, we needed the x value and the y value. In this case, we're going to end up solving for one of those values first. So we might get the x value first, we might get the y value first, depending on the problem. Once you have either the x or the y, you're going to plug into either equation. Okay, now I will tell you there's pretty much always an easier equation to plug into, so I'll show you that in the examples. Okay, but either equation actually works. To find the value of the other variable. Right? So remember, you're looking for the value of an x and a y. Here you're going to solve for one of them. Here you're going to solve for the other. And then, in order to check your answer, right, you're going to check. Normally you have to plug into both equations to check, right? But here you just plugged into one equation. So you're going to plug into the other equation to check. Okay, right? Normally when we're checking a solution, when we're testing a solution to an equation, we have to plug into both. But here we're kind of plugging into one already in step 3, so we're going to plug into the other in step 4. Okay, if you're still copying this down, please pause and finish copying because I want you to be fully focused on the examples. Okay, so here's the first example. Now what we're doing, the directions will say, solve by substitution. Okay, solve by substitution. And so here is our first system. There's this equation and this equation. And remember, a system is any two equations that share variables. So here, these are two equations. They both have an x and a y. So let's take a look at step 1. We're going to substitute an equivalent expression for a variable. Now remember, we're looking for a variable that's isolated. So let's look through these equations and we're going to find all the variables. Okay, there's a variable here. Okay, you don't need to circle, but I'm just kind of lightly circling so you can see. There's a variable here, there's a variable here, and there's a variable here. Which one is isolated? Which one is by itself on one side of the equal sign? It's this one here. So here is my variable that is isolated. Here's my variable that's isolated. Now, what's important to recognize is that this equal sign means that that variable is equal to this expression. So this variable and this expression are the same. That's what the equal sign means. So watch what I'm going to do. See this variable, this y? That's the same as this y. So if this y is equal to 3x minus 2, this y is also equal to 3x minus 2. So watch what I'm going to do in this next step. I'm going to copy this equation, but instead of that y, I'm going to substitute this equivalent expression in for the variable. So instead of writing y here, I'm going to write this. So watch, I'm copying this equation. 5x minus 3. Now this says 3 times y, but instead of writing y, I'm substituting in, right? Instead of writing 3 times y, I'm writing 3 times, and I'm taking this expression that's equal to y. Okay, so I have 5x minus 3y equals negative 10. So I've substituted in. Now, notice that this equation only has x's in it, right? There is no y in this equation. So now I'm going to solve, and I'm going to end up getting a value for x. So I'm going to start by distributing, right? I'm going to bring down 5x. This is negative 3 times 3. That's negative 9. Okay, that's negative 3 times 3x is negative 9x. Negative times negative is positive. 3 times 2 is 6. Okay, I'm going to keep solving. I'm going to combine like terms here. These are like terms. 5 minus 9 is negative 4. Now I need x by itself. I'm going to subtract 6 on both sides. Okay, that cancels this 6. I'm left with negative 4x equals negative 10 minus 6 is negative 16. And if I want x by itself here, right now it's being multiplied by negative 4, so I'm going to divide by negative 4 and divide by negative 4. And I get x equals negative divided by negative is positive 4. Okay, so notice I did, step 1 was right here. This was step 1. Okay. Step 2 was all of this. I solved, and I got a value of one variable. Now, here's step 3. Okay, I'm going to take this variable, and I'm going to plug it in. I know now that x is 4. I'm going to plug that value in. Now, I can plug it in here for this x in this equation, or I can plug it in right here for this x in this equation. And I will tell you, this one is way easier, because look, if I plug in 4 for x right here, look how easy this is for me to solve. 3 times 4 is 12. 12 minus 2 is 10. And I'm done. Right here, I would have had to multiply, then I would have to subtract, then I would have to divide, right? Too many steps. So now, here's what I'm thinking. Okay, so that was step 3. I plugged into the other equation to solve. So this is step 3 right here. So now, my answer is that, look, right? Remember, it's always x and then y. So let's see. My x value is 4, and my y value is 10. Okay, so that's my answer. I'm pretty sure that's my answer. I'm going to check it. Okay, here's my step 4. I'm going to check it, and I'm going to just use the other equation. So see how I just plugged in x into this equation? I'm just going to check it in the other equation to make sure. So I'm doing 5. Now, and this is just what you've already learned about checking an answer. 5x, I'm plugging in 4 for x, minus 3y equals negative 10. Let's check. 5 times 4 is 20. Negative 3 times 10 is negative 30. Is 20 minus 30 negative 10? Sure is. Okay, so that means this was correct. This was my correct answer. Okay, I'm going to do another example so you can see it again. Okay, again, I want to solve by substitution. Here are my two equations. Okay, again, I'm going to first look from all 4 of my variables. There's variable, 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 variable. which one is isolated? Which one is by itself on one side of the equal sign, like this? It's right here. It's this one. Notice in this case, it happens to be an x. Okay, and it is equivalent to this expression. It's equivalent to that expression. This x here is the same as this x here. So what I'm going to do is I'm going to take this expression, underlined in pink, and I'm going to substitute it in for this x up here. So I'm going to recopy this equation, this top equation, and I'm going to take that x and I'm going to substitute in this expression. Okay, this says negative 4 times x. I'm going to write negative 4 times, and then I'm going to put in something that's equal to x, which is this expression. And then that's negative 4x plus 2y equals 16, plus 2y equals 16. Okay, notice it's really important that I'm neat here because you have to be able to recognize the difference between an x and a y. So if you have messy handwriting, slow down. Okay, let's do the math here, right? This was step 1, I plugged in. Now step 2, I'm going to solve. Now notice this time I have only y's in my equation. So when I solve, the first variable I'm going to find is not going to be an x value, it's going to be the y value. Let's do it. First I'm distributing. Negative times negative is positive. 4 times 2 is 8. It's 8y. Negative times positive is negative. 4 times 1 is 4. I'm going to combine my like terms here. I'm going to add 4 to both sides. And then divide by 10 to get y by itself. And I get y equals 2. So notice I now have the value of one variable. In this case, it happens to be the y. Why? Because look, here I just chose the variable that was by itself. In this case, it was the x. Up here, it was the y, so it just ends up affecting which order I solve in. Okay, so now I'm going to take this y value, and I'm going to plug it in. Which equation should I plug it into? I can plug into either. This one will be easier. The one where the variable is already isolated will just be easier because it already says x equals, right? That's what I'm trying to figure out now. I already know what y is. So here's negative 2 times y, negative 2 times y, my y is 2, plus 1. Negative 2 times 2 is negative 4, plus 1. X is negative 3. Okay, so I think my answer is, okay, now careful here because you found the variables in the other order this time, but it's still, the x value still goes first, right? Even though I ended up finding it second, when I write my answer in an ordered pair like this, the x value goes first and the y value goes second. Okay, so now let's check. Right, so this was my step 3. I solved for the other variable, and here's my step 4. I'm going to check. And I'm going to check by plugging it into this other equation. So I have negative 4 times x, okay, and this is familiar to you. This was what we did in assignment 2 and 3. And plus 2y, y is 2, equals 16. Negative times negative is positive. 4 times 3 is 12. 2 times 2 is 4. 16 equals 16. Looking good. So now I feel comfortable boxing my answer. And that's it.